Hello viewers, welcome. So I have come up with a challenging problem on rotational mechanics from the book Pathfinder for Olympiads and JEE Advanced Physics. So this was also a problem which was requested to be solved. So this is not a simple problem by any means. Let's get on with the problem. A square lamina ABCD with one of its flat faces on a horizontal floor is sliding on the floor. At an instant, velocity vectors of the corners A and B are perpendicular to each other and the corner C is moving with velocity V at an angle CD. So let us draw the figure. So this square plate is moving on floor, that means the whole thing is happening in the horizontal plane, and here's G is cross, it is downward into the plane of the paper or board. So A, B, C, D, these are the sides. Now suppose I name the center of mass as E. Okay. Now what is given in the problem? At an instant, velocity vectors of corners A and B are perpendicular to each other. So say velocity vector of A happens to be like this, maybe other way also. So if velocity vector of B obviously has to be like this, perpendicular. Okay, see, obviously B cannot have velocity in this, this direction, because velocity of approach between 2 points is 0 on a rigid body. So this is these are velocities VA and VB, they make angle 90 degree. So that's, if I extend the vectors V and VB, so this should be 90 degree. So slightly the figure must also look like 90 degree angle. Okay, yeah, so that's, I'll draw like this. So this is VB. Yeah, now it looks like 90 degree angle between the two vectors V and VB. Okay, let's see what else is written. What else is given in the problem? A and B perpendicular to corner C is moving with a velocity V at an angle CD. Suppose corner C has velocity like this V, and which is making angle theta with CD such that tan theta is equal to half. Okay, now let's move on. So these are the sides A, B, C, D. Now say we consider the XY plane. This is the X axis and the Y axis. So we consider the angular velocity omega for the square plate, and say the diagonal of the square is suppose D. So D, 2D is the diagonal of the square. 2D is the diagonal of the square plate. Okay, so now angular speed of omega. So that means say this velocity of A is d omega, and velocity of B, with respect to the center E, that is also d omega. Okay, so this is d omega by root 2. So that's also d omega by root 2. This I am talking with respect to E, center of mass. So that's also d omega by root 2, and that's also downward d omega by root 2, and this side, so that is itself d by root 2. So this, say, midpoint P, and we have to ultimately find out velocity of this point P, midpoint of the side AB. So that is also in this x axis, d by root 2 omega. Now suppose d by root 2 omega we consider as A for simplicity, so that we don't have to repeat all these terms. So d by root 2 omega you substitute as A. So let d omega divided by root 2 is equal to A. Okay, and velocity of the point E, let velocity of the point E be v1 I cap plus v2 j cap. So we can write this, let velocity of E is v1 I cap plus v2 j cap. Now I will superpose this velocities. Okay, however, I missed out this point C. What about the point C? Point C will have components of velocities A to the left and A upward, and along with that you have to superpose this v1 and v2, right? So that you have to done with every that superposition you have to do with each and every. So that's v1 and v2, v1 and v2. So you have to superpose velocity of E with all the points. Somewhat looks like this. Okay, so these are A and A, right? So this A and A, this is with respect to E, and again you have to add velocity of E, that is v1 v2, you have to add with all the points. Let's move on. So this is after adding all this velocity. See, just we have just added this A plus v2, right? So here it will be A minus v2 to the left, this is A plus v1, this is A plus v2. So like that, after superposing and adding velocity of E with all the 4 points, this is how the velocities are, right? Now this is the combination of the velocities. See, this is A plus v1. Now this vector sum is equal to VB, right? Sum of this is equal to VB, and there it is VA, and that is VC is equal to V, right? VC, I mean this mod VC is equal to V as mentioned in the problem. Now we have framed up some equations. Now you know this angle theta, the velocity V makes with the line CD, so tan theta equal to half. So we can write na A minus V1, see this component A minus V1 is equal to V cos theta. Similarly A plus V2, I mean the y component of velocity of point C, so A plus V2 equal to V sin theta, and again VB and VA we can express in terms of I cap and J cap. So you know VB will be A plus V1 I cap plus A plus V2 J cap, and VA will be A plus V1 I cap minus A minus V2 J cap. So this is, you know, VB dot VA is equal to 0 because the angle between VB and VA vectors is 90 degrees. So this is just VB expressed in terms of I cap J cap and VA dot product 0. So ultimately you get this term, this equation. So you get equation 3. Again, what we want to find out is velocity of the point P. So velocity of the point P, you see this this has component, x component is A plus V1, y component is V2. So Vp square is A plus V1 square plus V2 square. Let's move on to next page. Yeah, now just again I have just rewritten the equation, this equation 1, 2, 3, 4. Now from 3 and 4 what do you get? From equation 3 and 4 you get Vp square, that means see A plus V1 square is equal to A square minus V2 square. So I'll substitute here. So here I substitute this A plus there A plus V1 square, I will substitute as A square minus V2 square. So that means you get Vp square equal to A square, that means Vp is equal to A. Okay, Vp is equal to A. Now from 1 and 2 again, so this is, you can note down this, Vp is equal to A. Now from 1 and 2, what do you get? From 1 and 2, you can substitute V1 and V2 in terms of V cos theta and A, like that. So from 1 and 2, you extract the values of V1 and V2 and substitute this in equation 3. Our target is to find out A, that's why. So here, see, in equation 3, I am substituting in equation 3. See, A plus V1 square. See, from equation 1, V1 is equal to, so A minus V cos theta, see, plus A minus V cos theta square equal to A square minus V2 square, A square minus V2 square. So V2 is equal to V sin theta minus A. So in this way, go on substituting, go on just writing the equations as it is. Try to simplify the equations as it is, and see, cos theta is 2 by root 5, sin theta is 1 by root 5. So just have a look at this equation. So here it is. So ultimately you get something like that. Yeah. And then, so that's a quadratic equation in A, and you solve this quadratic equation, you get A. So that's the final solution of A. A is root 5 plus minus 1 divided by 4 multiplied by V. So that means Vp. So Vp is same as A. So Vp is either root 5 plus 1 by 4. Vp is either root 5 plus 1 by 4V or root 5 minus 1 by 4V.